Now let's introduce our LoRaWan Street Light Controller API documentation. All of our LoRaWan Street Light controllers are developed in accordance with this API document. Therefore, users need to be compatible with this API document when doing application server development. This API document exists as a user data field in the LoRaWan packet. We are mainly brief introduction. The data composition of the API document. There is also a calculation method for each part of the data, especially the method of joint teaching. Other details in the documentation require the user read the document carefully. First, we can see each of our API. The command is made up of 4 parts. The first byte is the command code for the API document. The command code represents the function to be performed by each API command. The second byte is the data length of the API command data frame. It is the sum of all bytes of the API command data frame. The third part is the data field of the API command. It is usually composed of less than 10 bytes of data. The last byte is the check byte for the API command. Our API uses a verification approach. The calculation method of verification, we can see the description below. It runs from the first byte of the command code to the second last byte. The sum of all the data. And then with 0xFF language test. We can briefly demonstrate how the check is calculated. For example, now there is a frame data 0x180x060x, E30x120x08. Then the last byte should be the check. But we don't know what the check data is right now. Therefore, we need to calculate this API data. Let's turn on the calculator. Switch to hexadecimal mode. Accumulates data from the first byte to the second last byte. Zero x18 and 0x06 and 0x E3 and 0x12 and 0x08. The hexadecimal we calculate is 0x11b. But we need to operate on 0x11b and 0SFF. After operation, we get 0x1b. Our final result is 0x1b. This is the check that we calculated. Now let's take a look at it. This API document covers all the functions represented by command codes. We can see this table, a list of command definitions. In the list, each command code represents an operation of the API. Operation for Street Light Controller. There are some command codes with a CK response, but some command codes do not have a CK response. A CK responses are: what if our application server, a command was sent to the street light controller? Whether the street light controller will feed back a command to our application server. If you want feedback, in that way, the command code for this API data should be returned with the number starting with a CK in the table. Let's take a look. We control all the API, all the command code represents the function. I'm just going to give you some examples. First, the first command, 0x18, is also a very common command. This is a command to adjust the brightness of the street lamp controller. When the street light controller receives the command 0x18, it will adjust the brightness of the street lamp according to the brightness value set by the API command. Let's look at it again. 0x68 API command of the command code. It stands for our application server queries a command code of the terminal device through LoRaWan. Which information is queried on terminal device? We can see a detailed explanation of the order. Let's look at it again. This command from 70H. This command stands for the application server delivers the working mode of the street light controller. Each street light controller usually has 3 modes of operation. Includes manual control mode, including light sensing control mode and continuous control mode. To switch between different modes, the application server needs to switch through the 70H command. Let's take a command 0x18 to explain what this command consists of. This is a command to adjust the brightness of the street lamp. The command code is 0x18. Hexadecimal must be noted. The second byte represents the data length of the API command. It's made up of 4 bytes. The third byte is the user data field data. So this command at 0x18 means the brightness value of the street lamp. The last byte is the check. The brightness value of the street lamp. Set the range from 0x00 to 0xC8. 0xC8 is converted from hexadecimal to decimal. We can see that the decimal conversion is 200. 0x00 represents 0% street light brightness. 0xC8 represents 100% street light brightness. That means our brightness adjustment is based on a 0.5% to make adjustments. Then the command has data returned. The command code returned by the data starts with 0x98. 0x98 is actually 0x18 plus 0x80. All other command codes, the command codes returned by ACK, are calculated according to this mode. The command code of the return code is the data obtained from the command code of the receive code plus 0x80. 0x18 data returned data API data, field composition and 0x18. The API command to receive the data is the same. The first byte is the command code, second byte data growth degree, the third byte represents the current brightness value of the controller. The last byte is the check. Let's take an example. The application server platform sends a command. Want to set the brightness of the street lamp controller to 50%. So in our application server, we need to send this command to our street light controller. 18 represents the command code. 04 indicates the data length. 64 means that the brightness of the street lamp needs to be adjusted to 50%. The last byte represents the check, so let's calculate it. Just the way we calculated it. 0x18 plus 0x04 plus 0x64. The resulting check result is 0x80. Let's look at setting it at 50%. So why is the data field 64? 64 is a hexadecimal number. We can convert it to decimal. The result is 100. Our brightness adjustment step size is 0.5%. So 100 is actually the current. The brightness you need to set is 50%. And then when our controller gets it, after the command is sent by the application server, it's going to return a piece of data to our application server that starts with 98. Okay, so this is our API documentation, some data conversions and a brief introduction to computation. More details require the user to review the documentation